hopefully you actually tried typing this in. I know there's kids who can't type stuff in. Of course, depending on which calculator you get. Some calculators, you see the radical and they open up parentheses. Anybody got one like that? Yeah, yours. So what you're supposed to do, you don't necessarily have to when it's something simple like this. You're supposed to close it off. You're supposed to. You don't have to, but you're supposed to on something like that. But if everybody typed it in correctly based on the calculator they had, you should have seen non-real answer. What's another word for non-real? Imaginary. That's why these are called imaginary numbers. Believe it or not, some nerd created imaginary numbers, and some other nerd saw his work about a couple of months later, and he was studying electricity. And he needed a little bit of math. He needed new math to make it work. It was about the study of electromagnetic currents. So we could actually transfer electricity over power wires and create transistors and resistors. You wouldn't have electricity without the concept of. This is the way history works. Somebody creates a new math. Somebody catches on, sees it. Somebody actually applies stuff, usually an engineer or designer. And then they get run with it. They get something new. In this case, it was electricity. Anyways, the nerd that came up with this said he had a lot of problems figuring out things that should have answers, but he just couldn't figure it out. The problem was he was trying to take roots of negatives. So he said, okay, I'm going to let this letter I, and this lowercase I, stands for imaginary number, be defined as the root of -1. I is defined to be, don't worry about that. I'll give you a hard copy. Just remind me, and I'll print you out a hard copy, okay? I is defined to be the root of -1. The reason we do that is because we can square it. You square the I, square the left, you've got to square the right. What's that? When you square I, you get what back? What does a square do to a square root? Yes. You cancel out. You cancel out the square and square root, what's left? No. -1. The stuff inside is left. The pieces annihilate each other. They free it up. I squared is defined to be -1. Now, this doesn't let our calculator handle measuring numbers. It's not programmed really to do that in such a degree. It can do some work with it, but not all of it. It cannot take the square of a negative number. You already found it out, didn't you? There is an I button, by the way. It's right next to the 0 key. Might be important later. But the human brain can figure out things now. Like example A. A couple weeks back, you learned a property that said you could break a single radical into two radicals. The root of 4 is the root of a -1 times the root of a +4. Anybody doesn't understand that? Because you would multiply the interior back together and you get back to root of -4. What is the root of -1 defined to be now? It's I. This piece right here is I. And you better know what the root of 4 is. It's 2. Now, I'll probably use this word a lot. That's ugly. Make this stick. It's freaking ugly. That looks stupid. You don't put an I before 2. You don't put X before a number, do you? Why would you put I before a number? How do you think it should look? 2I. 2I. If I was dating, one of those, even if it asked me, would not get a date. The other one would. 2I. That's kind of the gist of working with imaginary numbers, the beginning of it anyways. It does obviously get harder. It can't all be easy. Example B is one where we have to do a little radical simplification. So let's try to kind of maybe just come up with the answer in 2 lines instead of 3 here. Could you pull a -1 from 32? Yeah, you could. There's a -32 there. Pull it. So we're going to say, okay, this is really the root of a -1 times another root. And then that root is a +32. But radical simplification is something you learn in this freshman. 32 has factors. What are they? 9, 8, 9, 4, 8. 4 and 8 does, but
16 and 2.
Prepare. Problem with 4 and 8 is you can still work with it. You want the biggest pair of factors that you take the square root of. Not something in the middle. Biggest set. That's 16 twos. Now, what's the root of this -1? What's the square root of -1? I. We're going to kind of put that on the back of the bus. Where it belongs, isn't it? Now, what we kind of suggested with the 2 i's that it belongs towards the back. Okay. What's root of 16? 4. When you pull that out, is it added to the radical or multiplied to the radical? Multiplied. So what's left in the radical is a 2. Now, mine's kind of got some spaces in here. That's 4 roots of 2i. When I was a kid, they encouraged us to put the I before the radical. And I kind of encourage y'all to do that too. Because you might think it's stuck in the radical. If it's not typed out, and it's my handwriting, you might think that I exists in the radical. So you'll probably see me put that I in the middle. Either version is correct. There's a reason it goes the way they did. It's because we wrote everything down. All right, now, after doing 2 of these, I'm not ever going to show all this breaking apart stuff anymore. I might show a step or 2, but example C, is it real or imaginary? It's imaginary. So what you do is you throw an I out front, and what do you do with the negative symbol? Ignore it. Now, does anybody remember how to break up a root of 3 over 49? That's right. Andrew says it's the square root of 3 over the square root of 49. Can you take the square root of 3? Can you take the square root of 49? What is the square root of 49? 7. So I roots of 3 over 7 is one way. The other way when you were dealing with fractions is to put it on the level, not up high, not down low, on the level. Or root of 3 over 7, and on the level of that divisor symbol, the I. I wouldn't stick it with the radical. I really would not. It look like it's in it. And that is the simple ones. Anybody got any questions on that before we move forward? Well, I know what some of the problem is. Y'all don't want to break radicals apart. You don't know your square roots. Like if I gave a quiz right now that asked for, I don't know, the square root of 64, there'd be a lot of zeros. I know there would be, especially if I took away your calculators. Much less radical simplification. That all goes back to 4th and 5th grade, kids, every bit of it. You learned your squares in 4th grade when you learned what 8 times 8 was, didn't you? That's when you learned it. On test days, I encourage you to push buttons on a calculator, but on non-test days, you shouldn't. All right, your next formula quiz is going to have these 4 added to it and probably some other stuff too. Powers of I. You already know 2 of them. What is I? That's good. Get that blank a lot. But you know today, I is root of -1. What happened when you squared I and created I squared? It was -1. Now, when you were in algebra with Miss Garner, I guarantee you she told you that x times x squared was? X squared. No, she did not tell you that. What's x times x squared, kids? X to the 3rd. You add exponents and you multiply. X to the 1st times x squared is x to the 1 plus 2, which is 3. That's how you break apart I cubed. I cubed is I squared times what? No, there are no x's. It's times I. We're not going to put root of -1 in there. I is easier to look at. It's pretty on the nose. We're just going to leave that 9. Now, what's I squared worth? If you don't like this, go home and put the power, please. When we teach this stuff to you so that the next generation can recreate the world you live in. That's why it's taught. Somebody has to recreate everything every single generation, don't they? Somebody has to. Knowledge has to be out there. You can't have a huge generation gap. If there was an entire generation that was never taught math, what would the world look like? It wouldn't be one. It wouldn't support population in the first place. It wouldn't be a world enough. You guys need to hurry up and learn this, not for your sake, but for the next generation. All right, now what's a negative 1 times I? Don't overthink this. Just negative I. I cubed is negative I. Where it is. How could you create an I to the 4th based off the previous stuff we just talked about? I squared times I squared. That's what I to the 4th is. What's every I squared worth? So negative 1 times negative 1, which ends up being 1. Yeah, like I said, your next formula quiz is going to have those 4 things on it. I is root of negative 1. I squared is negative 1. I cubed is negative I. I to the 4th is 1. Those 4 are on there. They're easy. I can already tell you who's going to miss it. Hunter, you're one of them. Now, next up is simplifying things that have I's in them. There is a pattern here, but I'm not going to teach you patterns and shortcuts. There's a kid adamant that he share it with another class. I had to shut him up. If you're not smart enough to realize there's a shortcut, you shouldn't be taught the shortcut because you will never remember it. Plain and simple. Teach somebody a shortcut, they don't remember the shortcut. Shortcuts have to be come up with on your own right. So there are shortcuts to this. I'm going to show you the actual math behind it. I to the 7th. By the way, this guy is the most important guy. This I to the 4th. It is so important. It's the key to this stuff. I to the 7th would be I to the 4th times what? Times I to the 3rd. Probably should have already had you guys memorizing exponent rules. Like terms have their exponents added together when you multiply. Now what's that I to the 4th worth? 4th of 1. What's I cubed worth? It's worth a what? Negative I. And it does look, I really don't like to use this word. I use it all the time because I don't know a better adjective. It just looks stupid to leave something like that. Aren't ones understood? They are. I know there's a couple of kids I have that are not understanding that. It's kind of the reason I hate to say dumb or stupid, but it's understood. It's there. There's no point in writing it. Negative I is what you're left with. Example B. How many times that 4 and that 12? 3 times. So it's an I to the 4th, and I'm going to make this longer than I have to. But what you could say is you'd say it's I to the 4th times I to the 4th times I to the 4th, which is a lot more typing than I care to do. That happens how many times? 3 times. So instead of saying I to the 4th times I to the 4th times I to the 4th, I could say I to the 4th all what? 3. I to the 4th cubed. That handles that I to the 12th. The next one, that plus I cubed, is really easy. What's I cubed worth? You just wrote it down your notes. So minus an I. Don't say plus a negative, just say minus I. The kids who do plus and minus, they just don't get it. I don't know why it's taught. Now, think for a second, because I know some kids don't get it. Just think to yourself for a second what 1 cubed is. And if Jace has it, that means that everybody has it. Jace, what is 1 cubed? Oh.
Negative I.
Oh. It's 1. 1.
Well, nobody has it.
Jace, this is to help you remember. I to the 4th is 1. You can remember that? I didn't do that to be mean. You understand? I didn't do that to be mean. You can remember that, aren't you?
I do that all the time.
Well, there you go.
Can you remind me? I'll do that.
Do not show that to your parents.
Listen, Milbrath told me this. I don't know any time. That's a long number.
So what's our answer?
Negative I.
No, it's 1 minus I. 1 minus I. You can't combine those things. One's real, one's imaginary. Why don't you guys try to see?
I think he's.
No, stuff you do is usually harder than I do.
Honestly, what fun.
Come on, kid. IQ is easy to replace it.
Oh, okay.
Try and do a little work on paper. It helps. I did look at some of your algebra tests. I wonder if y'all think that you can pass an algebra 2 test without doing algebra. Algebra is great to solve the problem, but you can't do algebra. Times 3. I have you go first IQ. It's not. I read some stuff right here. Kids, don't be thrown off by this. All right, let's try. I guess I'll go over it. What's that IQ worth?
What? Negative I.
Like, this is why I highlighted it. I cubed is negative I. So that's 3 parentheses negative I minus 4. I don't understand why you're confused. You don't even write anything down.
I got that.
Are you trying to figure it all out in your head without writing stuff down? Don't do that. How many times 416?
4 times.
So this is I to the 4th to the 4th.
I have that. It means go. I just erased it for the first time.
What's I to the 4th worth? 1. Jesse, what's 1 to the 4th power? Huh? Yeah, it's 1. That's a negative 3i minus 4 times a 1, which is what? This is negative 3i minus 4, but the problem is that's fugly. Very fugly. You might know why it's fugly?
And it's
In the wrong order. In the wrong order. I didn't talk about the order yet, but that's in the wrong order. What do you think is more important, real or imaginary?
real.
Real. A negative 4 belongs out front. That's the way it's supposed to look, kids. It's supposed to look like that.
I see that said F word and L1.
Factorly? That would be the F word in here, factorly.
Yeah. I'm talking about other F word.
Funly? Fractionally?
Some are really cool though. It's like the F bar.
No, we don't use that word. We're not gonna use that word.
Something my teachers call me failure. Yeah. I know.
All right, kids, that's those. Skipping those, don't have time for them. This is the overall goal, to be able to answer equations that before you couldn't answer. There's a reason these equations can't be answered. They're not hard. Just do the exact opposite of whatever it says in front of you. Like you see a -7. What is the exact opposite of subtracting 7?
Adding 7. So you add 7 to -31, and what do you get?
24.
3x squared is a -24. Now the goal here is to isolate this squared piece. Divide by 3. -8. Nick, what's the opposite of squaring?
Can I say it? Can you say it?
No. Dave, what's the opposite of squaring? Square root.
Yes.
Take the square root of both sides. What's the square root of x squared?
X.
X. Is the root of -8 real or imaginary?
Imaginary.
So what do you got to put in front of the radical?
I.
I.
Oh.
Now, other than simplification, am I missing anything?
No. Yes.
What was the exponent?
2.
How many answers am I supposed to have?
2.
What did I forget?
Negative.
Plus or minus? 2 answers, kids. You have to have 2 answers. Now, that thing is kind of ugly.
Yeah. You need to flip it up.
Why is it ugly, Tyler? Why? There's nothing to do with real numbers come first. It needs to be simplified.
Oh, 4.
The root of 8
4.
is the root of 4 times 2. What's the root of 4?
2.
2 root 2. I'm going to say x is plus or minus 2I root 2. You can say 2 root 2I if you'd like. Yeah, I was taught to put it in the middle. So that's how I tend to do it. There's nothing wrong with that answer. I mean, I know you're a little scared of it, but it's the prettier version.
Did you take that answer?
Yes, it's the correct answer. It's the same thing as plus or minus I root 8. It's just been simplified. All right, example B, 5, parentheses x minus 2 all squared plus 5 equals a -45. We're going to do this with the same procedure we did the last one. We want to isolate the squared thing. No, you cannot. You cannot distribute that 5 because there is not. This is not x minus 2. That is x minus 2 squared. You write it twice, spoil, you get something entirely different. You cannot distribute that 5. Milbrath has never shown you that. Milbrath will never show you that. If you listen to me instead of interrupting me with a suggestion that's obviously freaking wrong, you would try to isolate what?
X.
Squared.
Squared. Isolate the squared component. I'm not trying to get on to y'all, but you sit here and you pay 30% of your attention to me, and you don't listen, you think you have your own ideas, I give you a quiz, you make a 30. For God's sake, listen to me. You don't believe me, but Algebra, Dresden High School is one of the top 10 schools in Tennessee to learn Algebra 2. That's backed by state data. You guys take your little tests. There's been one teacher here for a long time. It's me. Maybe you should do things the way I suggest you do it. You might get a good subject. Not done isolating. Divide by 5. You can go ask any teacher here by according to testing data who the best teacher in the school is. I am the only level 5 teacher in this building. Fact, kids. I ain't bragging about it. Miss Adams probably will be next year. She's testing. I said testing. What's the opposite of squaring?
Square root. Hey. I remember a time that we did that.
Root -10, real or imaginary?
Imaginary.
What are you going to throw in front of the radical?
I.
What else are you going to throw in front of radical? Plus or minus. The radical canceled out the square. Now you can isolate x. I do what? Now you do. Now here's what you see a lot of. You see stuff that looks like that. I don't even know why I circled it. It's ugly.
It's so
No. Put the 2 in front. It looks really weird to put a plus or minus symbol when there's nothing in front of it. Like this kind of bothers me a little bit. I want just like a plus or minus symbol there. There's something in front of it. Put the number in front of that. That makes more logical sense. Doesn't it? You'd say, oh, 2 plus this or 2 minus this. You wouldn't say plus I root 10 plus 2. That just doesn't make sense. Normally we do the U try, but we ain't got time, so we're not going to do the U try. It's going to be done exactly the same way B was done, by the way. Subtract 30, divide by 5, counteract squaring with square roots. All right, here is the actual definition of complex number. It's its mathematical definition. The big part is we talk about the proper form. It is any number written in the form A plus BI. Scroll through your notes you just took. How did I write every one of those answers? Real, plus or minus, imaginary, didn't I? Where A is real and BI is imaginary. Quit talking to each other. Both of you are failing. I'm so tired of caring about kids who don't care. Wish I could make you care. I wish I could. Yeah, a little more of this. Let's see. Real numbers are a subset of complex numbers. Now, you probably have no idea what that means, but it means all numbers are complex. Even like the number 3. Usually when you see 3, you'd think that's real. You could hold 3 somethings in your hand, right? Yeah, it's a real number. 5 halves is real. Those are real numbers. Even 3, because 3 can be written as 3 plus 0i. All numbers are complex numbers. Now, do you guys remember learning your little sets of numbers in maybe 7th, 8th grade? You had your integers, your whole numbers, stuff like that. Certain things were a part of others. Do you remember some of that stuff? They probably had you do Venn diagrams. That's how it's usually taught. Complex numbers contains all of them. So it's top of the food chain. Now we're going to throw out example A because they're the same thing. This is addition and subtraction of complex numbers. And all you got to do is focus on like terms. We're throwing out A because if you can do subtraction, you can do addition. Subtraction is harder than addition. This. Here's what, hell, I don't want to show you what most kids do. To do this properly, you have to distribute your negative. You have to. If you don't distribute that negative, you're going to get it wrong. And a lot of you won't even write what I wrote down. That's just how lazy you are. I'm going to drop the parentheses around 2i because I don't need them. That positive 12 becomes what? Negative. That negative 3i becomes positive. It's that simple. Now, what pieces do you want to put together first? The real numbers first, because they should come first, right? That's 5 take away 12. Negative 7. What's a negative 2i plus a 3i? Plus a 9. That is how you add or subtract numbers, kids. You combine like terms. That is it. Swear to you, that's it. Will you miss on a quiz? You betcha. You will.
Just remember,
That's the one thing I'll never remember.
Now, here's the multiplication of complex numbers. Oh, geez, it's so hard to multiply things together. Boom! You guys can do this. Madison, what's 5 times Sonnet? 25 what? Alright. First part. Trey, what do you think 5i times negative 6i is?
Negative 30.
Negative 30, keep going. There's another. I. Trey, what's I times I?
I squared.
I swear. That wasn't so hard.
Oh, yeah, I forgot about that.
Look on your second slide. What's I squared worth?
-1.
No, they're up there somewhere. I squared was negative 1. If one of these kids sits next to you, you need to put your mask on. Replacement kids, on your notes, I squared is negative 1. What's a negative 30 times negative 1? Is it 30? Are you in that proper form? No. 30 plus 25 is your answer. Isn't that hard? I showed every single little step there. Did you need all those steps? Some of you probably do, some of you don't. You need to figure out that happy medium where you're getting your work right and not showing it all. That's what you need to figure out. How much work do you actually need to do so that you can follow back and see what you were doing? Figure it out really quick. And there is a happy medium there. If you're flunking all your quizzes and tests, you haven't found that happy medium. Not even close. All right, what's up next? How do you think we're going to handle this guy, the next one? Yes, you're going to FOIL. That is the product of two things. Yeah, the product of A plus B and A plus B. So, again, I did not look to see on your test how many missed the FOIL example, but I know kids did because I remember marking it wrong. There was a FOIL example on your last test, wasn't there? What's 6 times 2? 12. Plus something. 6 times 9i. Now, what I did is I distributed the 6 to both terms. This is called the double distributive property. When you're done with the 6, what do you go after next? Yeah, you go after that negative 3i. You don't have to know the acronym, kids. You just have to remember to distribute the first thing to both pieces and then the second thing to both pieces. What's a negative 3i times 2? Negative 6i. Now, Trey helped us with the last one. We did an I times an I. Hopefully you were listening to him. Dylan, are you still taking your test? No? Dylan, what's a negative 3i times 9i? Jace wants it. Squared. Took 3 of you. Jesse, what's that I squared worth? Yeah. By the way, the center is 54 minus 6. That's 48i. Jesse said that 27 was worth a negative 1. Jesse's right. Now, I'm showing every step here. What's that negative 27 times that negative 1? Plus 27. So combine your likes. It's 12 and 27 add to 39. That comes first, kids. That was multiplication of two imaginary numbers. Was it so bad? It's not. It's really not. We're probably going to run into directed studies. I'm sorry about that. Believe it or not, your notes 4 years ago, there were 10 slides on these notes, and I used to be able to cover all that.
Last year there was 9. This year there's 8. You said it, not me.
Go back to this page.
Since we're running over, I guess I will. Hopefully he won't talk. Here we go. We're not done. Pilot. A handful of kids got that right.
1 minute. Even on the multiple choice version, where you could use a calculator, you still missed it. It baffles my mind. Overall. What is the conjugate of 2 minus root 2? 2 plus root 2. You change the sign in front of the radical. It's one of the reasons we did it, to start talking about the conjugate. What do you suppose the conjugate, we're focused on the denominator if you read what it says. What's the conjugate of 2 take away at 4i? What do we change? Sign before the radical. What does that change here? Sign before the imaginary. Conjugate of 2 minus 4i is 2 plus 4i. You suppose the conjugate of a positive 4i is? Negative 4i. Now the problem with these numbers is they're not in standard form. They're not in that a plus bi form. That's why you work with them. You go for that form. This is how you fix it. You find the conjugate, you multiply the bottom by that piece. If it goes to the bottom, you go to the top. Hopefully you still got a calculator. Hopefully it's still on. Two or more wrap. That's why I'm wrapping all that stuff in parentheses. 2 or more you wrap.
If you ain't wrapping, mistakes happen. Your calculator's on? Or are they on? Did I hint there was an I key earlier?
Yeah, by the 0.
By the 0. If you will just look right by that 0 to its right, in blue, you will see an I. Now, I'm going to write it. I'm going to type it in just like I wrote on the board. Parentheses 7 plus 3i. If you don't have those parentheses, your calculator ain't going to help you. It's in blue, so hit second decimal point. Close those parentheses. I'm doing the top here, 7 plus 3i. What do I multiply it by? 2 plus 4i. If you ain't typing it in like I wrote it, you ain't going to get the same thing that I got.
Laptop, it's on low here. He's on his, they haven't got your laptop yet. Low here, nice.
Anyways, 2 plus 34i is what you should be getting.
Yes. You're not getting it, you need to see it typing things in the way I did. Jesse, you telling you that to you?
It's gone.
By the 0. To the right of the 0. The top turned out to be 2 plus 34i. Need to figure out the bottom. Once you guys figure out the bottom. You already ran over. Take your 30 seconds. Figure out the bottom pieces. Huh? It's 20. He typed in his calculator.
We got 40.
He typed in the calculator at the bottom. 2 minus 4i times 2 plus 4i. It's going to tell you 20. Of course, you always get a kid who leaves it like this. Is this in form A plus BI? No.
Close it.
Yeah, I would actually, I have a tendency to accept stuff like this if you clean it up, you simplify the numbers. That's how I would start.
True.
But you've got a 2 over a 20, right?
Yeah.
And you got a 34 over 20. What's 2 over 20 as a fraction?
10.
Not 10, it's 20 over 2. It's 1 over 10. If you don't know that, you go to your calculator, you type 2 divided by 20, enter, math, enter, enter. It'll tell you the fraction. 2 over 20 is a tenth. Plus 34 over 20, both even. What's it reduced to? There's a fraction.
Yeah, math.
If you got to. Anyways, what's 34 divided by 2? What's 20 divided by 2? 17 tenths. Don't forget about I. That's where we will stop. You got your homework in front of you. Okay, so if you gotta go to the bathroom, you gotta go to the bathroom, Ashton. Give me just a second, I need to stop recording.